So we're looking at an exponential equation here. And if you calm down for a second, you'll realize that it's two numbers, 27 and 9, that have something in common between them. They're both related to the number 3, and that's going to be really helpful when we look at it. If you want, we could just start there right away and say on the left we have 3 to the third power, and that's raised to the n squared. And on the right, we have 3 squared, that's 9, and it's raised to the 4 minus 5n power. Now, I think this is really great progress, because if we can just get those 3 base numbers, right, the biggest 3 that's on the bottom, by itself with just an exponent, then we can make some progress here. But the problem is I have multiple exponents going on. I have a 3 and an n squared on the left. I have a 2 and a 4 minus 5n on the right. So we have to remember exponent rules. And those are going to work in the following way. If I have an exponential number, 3 to the third, and I raise it to an exponent, that's the same as multiplying the exponents together. Okay, I'll do this again on the right so you can see what's going on. On the right, this is going to turn into 2 times 4 minus 5n. Okay, and now all of a sudden, like magic, it's just a single base, 3, and a single exponent. Now, the exponent is ugly. I'll grant you that one. But it is a single exponent, and that means we can come in here and do this. It almost feels like cheating. It makes it so easy. Just cross out the bases. Okay, because if 3 to a number equals 3 to a different number, those exponents have to be the same. Otherwise, this equation won't work. So that means 3n squared equals 2 times 4 minus 5n. Okay, and now this looks like a nice, pretty tame equation. I can just get rid of the parentheses and distribute the multiplication, and I get this. And now I hope you're starting to recognize that this is really just a factoring problem. It looked scary with the exponentials, but it's really just a factoring problem. And if we can just turn this into parentheses times parentheses, then we are basically done with this thing. Okay, I'll zip through the factoring kind of quick. I assume you guys already know how to factor. If you don't know how to factor, this very last step that I'm doing, it's time to go back to some earlier videos or look up that topic, factoring, in some of the work that I've done elsewhere on the channel. Okay, but I'm just going to do this in my head. I'm going to guess a 4 and a 2 over here. Okay, 3 times 4 is 12. 2 times 1 is 2. So I know that this must be a positive and this must be a negative. Okay, and if you guessed wrong, you just re-guess. There's better ways to do this than guessing, but I tend to use guessing when the problems are kind of small numbers like we have here. So from this one, I get n equals 2/3, and from this one over here, I get n equals -4. Okay. Now we look over here on the left and say which one of these is the solution set. It doesn't actually matter what order these numbers are going in. The curly brackets just means I'm giving you a list of numbers, and here's the list inside the curly brackets. So we just look over here and we say that one right there. Okay, that's my 2/3 and -4. Now that's the way you solve this in more of a, I'll call it a forward direction, right? You start at the beginning of the problem and you work your way through using exponential equality to cross out equal bases. And once you cross out the equal bases, you factor and you're done. There's another way you could have solved this, which is just to plug things in, right? And if you're in a time crunch, that's not a bad idea. For example, and if you're happy with the explanation I've given you so far, then you can just quit here. But what if I had just plugged in -2? What if I had plugged in -2 into that equation and found that it did not work? If I got different numbers on each side? Well, what that would mean is we can cross out -2 everywhere you see a -2 in the solution. Okay, so by guessing one number from this list, we just crossed out 2 answers. And if you're short on time, or if you have no clue how to do the exponential solving like I did, that might be a better strategy. What's the next number we could plug in? Well, you might guess -4 and get lucky. And if you did, great, you've got your answer. But you might also guess one of these other numbers, like +2. That might be the next thing you check. And if you plug in +2 into that equation, you'll see it also fails.